So now let's take a look at scaling. So when we scale a picture, we can scale it down, make it smaller, or scale it up. So we're going to look at two examples of that. So when we scale, what we're doing is, instead of copying every single picture like we do when we're copying or rotating or something like that, what we do is we sample the pixels. For example, if we are making a smaller image, we might sample every other pixel. That is, not copy all of the pixels to the new image, but rather copy every other one. If we are trying to enlarge or scale up an image, then we would want to oversample some pixels. That is, make multiple copies of each pixel. So this example scales down, and what it's doing is it's taking a larger image and scaling it down to half the width and half the height. So we get a picture that's 1/4 the size of the original. So we start off by making an empty picture that is half the width and half the height of the original. So we're just passing the source to get width and get height here. And then what we do is, this is just copying. We have our source X and source Y that are starting at 0, and the target X and target Y are starting at 0 and going across the whole target image. But we're incrementing source X and source Y by 2 so that we copy every other pixel, and so that's how we end up with the smaller image. Now, if we want to scale up, what we have to do is duplicate some of the pixels. And the way we do that is we oversample, and we do that by, instead of incrementing by 2, we're going to increment by a half. And so in our loop, you'll see that we're going to go 1, 1.5, 2, 2.5, and so forth, so that in the picture that we're sampling from, we'll copy every pixel twice. Now, of course, we can't get a pixel at position 1.5, so what we do is we use this int function to truncate the 0.5 and give us a 1. So in effect, by our counter, we'll go 1, 1.5, 2, 2.5, but because we use the int function, we in effect are going 1, 1, 2, 2, 3, 3. And in that way, we're copying every pixel in the source twice. So here's the scale up function, and so this is doubling, creating an image that is double the width and double the height of the original. And so you see that we're making an empty picture that's get width times 2 and get height times 2. And then again, we just have our loop. Source X starts at 0 and source Y at 0 and so forth, but we're copying every pixel twice by incrementing by 0.5. So our source X and source Y go 0, 0.5, 1, 1.5, 2, 2.5. But when we get the pixel, we use the int function so that we are not passing a floating point value to the get pixel function. We have to pass an int, and in that way we'll go 1, 1, 2, 2, 3, 3, and so forth. So here's how it works. So when the source X and source Y are at 0, 0, and target X and target Y are at 0, 0, it copies that medium blue pixel over. And then in the next iteration of the loop, source X or source Y will go to 0.5, but because we use the int function, we're actually getting 0, 0 again. And the target Y is going to increment by 1. So we're copying that same pixel over a second time down that column. And it'll do that with the black pixel as well when Y goes to 1, and then when it goes to 1.5, it'll copy it again. We do that all the way down the column, and then when we start again on the next column in that first row, that 0th row, it's going to, the source X is going to increment by 0.5, which is going to again cause us to copy that pixel yet another time. And so in effect, every pixel in the source is really getting copied 4 times to the target. Now, so that gives us a scaled up image. Sometimes when we do this, we end up with sort of a choppy looking picture. You may have seen this happen if you're in creating a PowerPoint presentation or something. You take an image and you try to zoom it up and make it look, scale it up and make it look bigger. It'll get this choppy, pixelated kind of effect. And so that can happen sometimes when you're scaling up. So I'm going to show you in the next worked example how to use the scale function and give you some hints on your hands-on exercise, which will be to create a more generic scale function so that instead of just always doubling the size or having it, we're going to pass our source image that we want to scale and a factor. So we might, if we passed it 0.5, we would scale it in half. If we passed it 2, it would double it, but we could also make it 3 times as large or 1.3 times or 30% bigger or whatever. So the factor is flexible there so that we can scale to basically any size that we want.